Hey, this is William with an update on my game Mutatis for the Atari 2600. I made some progress on this game during this summer. This is the game I entered in the Atari iRebel Game Jam a few months ago. They sent me this t-shirt. I started using more standard software versioning with this update instead of my previous methodology. I learned they call this naming convention semantic versioning. 3 numbers designate major, minor, and patch alterations. So I'm calling this version of the game 1.1.1 and the Game Jam version 1.0.0. I worked a bit on a title screen, but think I'll forego showing a title. The text. Working a bit on a game select screen, in my case probably 4 games, with slight variations to the gameplay, so I can make a cool game select matrix. The game select screen I played around with, the player selects which game to play with these dots. And these bars beneath that display the 2600's difficulty switches. This isn't integrated in the game though, still working on the design separately. If you remember those OG Atari boxes, they claimed includes 1,000 games or whatever, actually referring to alterations of the same game. I think it'd be fun to continue that tradition, as well as this level indicator meant to be seen as an interstitial between the levels. Still working on this concept if you pick a level or if it just moves automatically to the next level to show your progress as you're trying to get Mutatis out of the experimental facility. I removed most of the sounds from the game temporarily. Sound will be a separate challenge that I've decided to tackle last. I've also removed the mutations for the moment, so the player only has one form as I work on the rest of the game. I added some detail to the gameplay arena by using the top and bottom of the player 0 sprite. So this is Mutatis here in the middle, the player 0 sprite, and the animated containment machine above and below Mutatis. That's also the player 0 sprite, animated during the same 3 frames. I added explosions for when the player destroys an enemy with the eye of Mutatis, or an enemy runs into Mutatis. On impact, the player 1 sprite is redefined as the explosion. I also started adding new enemy types. This one, provisionally called the Speedster, appears on screen and makes a direct assault on Mutatis. It does not steal shield node pieces, unlike the Grabber, which is the only enemy type that does that. And you can block the Speedster with the shields, and it'll explode. But you cannot destroy it with the eye. Currently, the Speedster appears at regular intervals during each level. I'm using a 1-minute timer loop, and then everything repeats, which on my machine is roughly 70 ticks of the variable, 1 for each game loop. When I have all the enemy types integrated, certain types will only appear on certain levels, and I'll rethink the duration of the loop as I optimize gameplay. I haven't tweaked flight patterns or behavior of the Grabber yet, or the genetic neutralizer, which steals your Biota. The biggest change in this version is the inclusion of the Biota Mechanic. When this enemy type appears, which I don't really have a name for yet, but I'll call it the Biota Bug for now, they carry the Biota that Mutatis must acquire to mutate, collect 4, and the level changes, but the mutations are not in the game yet. To be honest, I'm not even sure which end of this sprite is the front. Either it carries the Biota at its back, or the Biota is in fact its head. I tried a few different variations of this bug before choosing the final sprite. As an aside, on the Biota itself, I recently watched a Gen X grown-up video about the Star Trek game for the 2600, which I didn't even know existed. And my Biota sprite is identical to what that game uses for Klingon ships. So either I will be stubborn and leave it as it is, or change it later, who knows, we'll see. So I started working on the flight pattern of the bug before settling on the design, so in these examples you'll just see the Biota sprite. For its erratic bug-like movement, I first tried some time-based code to suggest a nervous fly-like motion, so it moves in increasingly larger arcs before retreating. I liked some of that motion, but when the code started looking nasty and taking up so much space, I thought this would be a good opportunity to try data arrays again. If you've seen my past videos about Telemachus, my adventure game for the 2600, in that game I had successfully used a data array to determine where a teleporting space mine would appear and disappear. But later, trying to use an array again, it failed to be called, and I couldn't determine what had changed. Well, I had started using bank switching between those 2 attempts. The documentation I was using didn't mention you need to put the array in the same bank where the data is called. Recently, I found this answer on the Atari Age forums. So, issue solved, I went about designing a new flight pattern for the sprite. I placed some coordinates on a graphic and drew a path and then made two arrays, one for the X position and one for the Y position. This code here introduces random-like pauses, which I feel indicates the bug-like behavior that I'm after. Then I did the same thing for the other side. This bit operator determines which side the Biota bug appears on each time it spawns. In fact, it determines which side all the enemies appear on. As they fly off screen or are destroyed, this simple code flips the bit operator to determine which side the new enemy will appear on. For collecting the biota itself, I tried a few swirl patterns, but I found they took too long, and just increasing the speed of the sprite wouldn't help, because if it happened to overshoot the target coordinate, it would simply get stuck and stop moving. So at the moment I am using two swirls to collect the biota. Which one is activated is dependent on if the eye touches the biota bug on the left or the right. The X and Y values are called from these two arrays. I am temporarily using my damage timer variable from another routine since I am running out of variables. Incrementing this value changes the target pair of coordinates, moving the sprite through the path. I'd like to add two swirls on the bottom, so collecting the biota is particular to each quadrant of the screen. I also want to smooth out the swirl motion by including more values in the array, so the gaps between target coordinates are so negligible I can drop using math entirely, no longer adding mutant enemy S to mutant enemy X and Y, instead moving the sprite directly through the array values. Now with the Biota Bug sprite implemented, I added some horizontal flips of the sprite every few seconds to add to the bug-like impression. Remember, an 8 value does not mean left, but rather flip horizontal axis. Now that I have arrays working, I decided to simplify the litany of if-then statements that I was using throughout the code, like these, which I was using to determine the new Y position of the grabber when it respawned, based on my timer called microseconds. In my first attempt, I was thinking, well, I have 70 ticks per minute, and from 25 to 95 pixels, there are 70 increments. So that's perfect. I'll just input 70 values for a wide variety of possible positions. Well, when I typed in all those values, it returned a maximum line length error after I compiled, because I didn't even know data arrays have a maximum line length. Simple fix, though. However, this code resulted in the sprite spawning within a narrow range, always at the top. This led to a still unsolved mystery of various attempts for a more random-looking Y position. Each attempt was a varied technique. Nonetheless, it resulted in the same narrow distribution. I even thought maybe I was accidentally redefining mutant enemy Y somewhere downstream in the code flow, but that was not the case. I also tried using random, but received similar results. For the time being, I simplified the spawn array to this code as a temporary pseudo-solution for later experimentation. I did successfully adapt my arena level color code to an array, however, and it looks much cleaner. Then I tried to reduce my enemy speed and velocity statements also to an array, but apparently you can't use values intended for fixed point math in the array, and maybe there's a workaround or the syntax is different. Personally, the most exciting change to the game, I have now officially raced the beam. What beam? Kernels control how and what the screen displays, and Batari Basic includes a number of optional kernels, which you can implement in your game. Well, when programming in Batari Basic, you can access the screen space below the playfield by using a pre-made mini-kernel, or by writing your own mini-kernel in assembly. Batari Basic is a high-level language, As such, it utilizes language abstractions. The programmer kind of floats over the minutiae of the hardware, whereas with the more intensive low-level language assembly, one dives directly into the concrete. Since I wanted to create a custom status area below the playfield, and I knew that required assembly, I searched on the Atari Age forums to find a tutorial. Just starting out, but I managed most of the results I was after. The status bar on the bottom keeps track of both health and the biota that you've collected. I'll link the tutorial I used in the description. Here's a brief overview. I've got the game kernel in bAtari Basic, the mini kernel in assembly. Both files are saved in the same location. At the end of my multi-bank game file, I use an inline command to link to the mini kernel. Above that, I have several data blocks defining the sprite shapes and the colors I want to display them with, as well as the background color for the status bar, which changes per level. The variables in the bAtari Basic file, which hold the player's health and biota count, determine which data from these blocks the assembly file uses to display the mini-kernel. And the player 0 and player 1 sprites are repositioned, and the colors set. This return from subroutine instruction gets us back to the main kernel. Look over here. On the left, this little horizontal black line, they call this colloquially a comb, which is easier to understand why they call it that when it appears in multiples like this, as you may have seen on classic 2600 games. It occurred to me while making this graphic, the comb lines in Berserk are one scan line directly above the heads of the robots, and the copyright. They appear when player 0 and player 1 are repositioned horizontally on screen within the same frame. This is different than moving a sprite in its X value across multiple frames. This is the same sprite repositioned during the same frame. In other words, you're giving the appearance of multiple sprites, but they are really the same sprite, player 0 or player 1. You might think of it not as discrete objects displayed on screen, but rather as a beam drawing single scan lines, one at a time. And each of those scan lines may or may not contain data pertaining to the sprites, or the background, or the playfield. In my case, my game kernel is using the player 0 sprite as Mutatis in the center, the power structures above and below, that's all one instance of the sprite, and then again a second instance as the health indicator on the bottom left in the mini kernel. Likewise, the player 1 sprite is used by the kernel as the enemy sprite, and below in the mini kernel as the biota indicator. How? After drawing a sprite in one location, we then redefine its shape and position before the beam arrives at the new location. And if there isn't enough time to both run the code and draw to the screen, well, running the code takes precedence, leaving a sliver of the screen empty. And so the comb appears. You could say the comb indicates where we lost our race against the beam. For a much more thorough explanation and one that's also more scientifically accurate, I'll include a link in the description. This comb effect is also referred to as HMOVE Lines. What's HMOVE? Let's open up Steve Wright's Still a Programmer guide from 1979. Here's a chart of the Atari 2600 addresses on the TIA chip. Some of these I've been using directly in this game via bAtari Basic, like color playfield, color background, etc. Now, the 2600 has 5 registers you can manipulate for horizontal motion, one for each sprite, activated by HMOVE. But this horizontal positioning has timing restrictions. Why? We're emulating programming for hardware which controls a cathode ray tube television screen. And the 2600 needs time to activate its registers before the TV's electron beam starts to draw the next scan line. bAtari Basic essentially hides all this from us in the background, and we just change our X values in the foreground, so to speak, for our horizontal positioning. As I understand it, the assembly code in my mini kernel isn't running at the appropriate time regarding HMOVE's clock cycle demands. Now, I've read that these can be avoided if you time your HMOVE to occur on a cycle count of 74, but I don't know how to do that yet. At any rate, they kind of feel nostalgic, so maybe I'll just leave it. Activision is famous for masking out the comb by simply ensuring that area of the screen is black, so the comb is black over a black background. This aesthetic solution effectively reduces the screen resolution by a few pixels. So that's more or less everything. Still to code, an end screen facility escape, a bonus speed level, or maybe if the level timer hits a certain value, then there's more chaos or something happens. Game select options, difficulty select options, a few more enemy types like an eye catcher that grabs the eye momentarily, a poisoner that inverts the controls, and maybe an enemy type that drops health. The Mutatis mutations, Playfield variation per level, and of course sound. So I estimate I am now about 3/4 finished with Mutatis. You can download the current version of the game on my itch page, link in the description. And if you want to, feel free to leave any bug reports in the comments. Thanks for your attention.